Okay, here we go with today's assignment. This is the Friday right before the long weekend, or Thursday right before the long weekend. So we're going to do the reciprocal families, and we're going to look at what happens with this. What you're going to find out is it's very similar to before. Okay, direct variation is y is equal to k times x. That's going to be a nice linear relationship. Okay, it's something like y is equal to, if this was properly drawn, it would go right through the center. Okay, y is equal to 2x, something like that. Now, inverse variation is a little different. That's y is equal to k divided by x. So if I made a table of values for this, x and y, I chose 1, 2, 0, -1, and -2. If I put a 1 in there for the, and let's make this 1 is equal to 1 over x. If I put a 1 in there, this is 1. If I put the 2 in there for x, I get 1/2. If I put the 0 in here, I get undefined. It doesn't work. If I put -1 in there, I get -1, and -2 in there, I get -1/2. Well, this is the one that matters to me. What that tells me is it will never ever be 0. Okay, and then if I take my x values up here really large, if I put 100 in here, then this will be 1 over 100. Sorry, it'll be 100 and 1 over 100. So this will really get close to this axis, but it'll never touch it. And it gets close to this axis, but never touch it. So it looks like this. Now, if you notice, on the negative side, I'm getting the same thing. So it comes down and looks like this. All right, now this is what the inverse function always looks like. It looks like matching ones. It kind of looks like exponential decay in both of these. So that's what that looks like. So exponential, here we go. Y is equal to 1 over x. There is a vertical asymptote that's marked as a dashed line, and that's going to be up and down. So I'm going to put something like this. Now, an asymptote, remember, it gets really close to it, but it never passes. A horizontal asymptote, that's also a dashed line, but this dashed line is going to run horizontally. And then we talk about reflection and stretch. All right. Now, once I get these two asymptotes, then it basically graphs the same as all the time. So if I take y is equal to 1 over x, and if I make my table x, y, and if I put a 1 there, this is 1. If I put a 3 in there, this is 1/3. If I put a 1/3 in there, so it's 1 divided by 1/3, which is 1 times 3. So that's 3. So if I were to do this, I know it goes through this point right here. But all the rest of them are between 1 and 0. So it's going to get really close to this. And then really close to this one. Notice that right here, that's the vertical asymptote. Gets really close to that. And that's the horizontal asymptote. Notice that the horizontal asymptote is what causes the bottom to become 0. Actually, we'll play around with that. Now, the other one ends up going through, if I put a -1 in here, that's -1. So it goes to this point, and that mirrors it on the other side. Just like that. So if I have y is equal to 1 over x plus 2, okay? If I put a -2 in for x, then this equals 0, and I can't have that. So my x equals -2, there's my vertical asymptote. My horizontal asymptote, it's not moved up any at all, so it's still right here. Now, it always goes through one right, one up, one right, one up, and then one left, one down. That's my normal one. So this particular graph will look something like this. Notice how it's in, if I wanted to think about it, it's in quadrant 1 and 3. Always comes out that way, always graphs that way. Also notice I moved it 2 units left on this problem. So now let's say I wanted to go y is equal to 1 over x plus 3. So with that one, what I do is, now there isn't a number, so it's going to stay here, but it's going to actually move the horizontal asymptote up 3. Still goes through those 2 points. So the graph looks like this. Now, what I'm trying to get to is, this is very much the same as what we did before. If it's on the outside here, it's a vertical shift. It goes up and down. Up if it's positive, down if it's negative. If it's underneath there, so if it's inside here, this is going to be a horizontal shift. The left is positive, the right is negative. Remember, it's always the opposite. And the A value, the number on top, tells me if it's a stretch or a compression. Okay, basically if it's a number bigger than 1 or a number less than 1, and then a reflection. Okay, so I want to say the reciprocal function, which is y is equal to 1 over, and I've shifted to left 2, up 3. Now I want this to be reflected and stretch it 2. There we go. Just exactly the same as what I did before. It's not much different than at all from this. This makes this assignment go pretty quickly. Now this one, what I always do is I find the asymptotes. So there's that one. Here's this one. It's not stretched, right 1, up 1, so that works. It's not stretched, it's not reflected because it's 1 and 3. But I did move it left 2 and down 1, 2, 3. So what I'm doing is I'm taking this point, I'm moving it here and then here. This one. Okay. It's not stretched, but it is reflected. And I didn't move it left or right because right here it is, but I did move it up 2. All right, so now this one I have to graph. I have x equals negative, so I moved it left 2, but I didn't move it up. It's not stretched, not reflected. I hit those 2 points. There you go. I moved it right 1 and up 3. Up 3, right 1, through that point, because it's not reflected or stretched, and through that point. Reflected, up 3. Reflected puts me at these 2 points. Stretched, reflected, left 1. Let's do the left 1. Reflected. Now, instead of going through 1, 1, I'm going to end up going through 1, 2, and 2, 1. 1 over, 2 down, 2 over, 1. Now, if I chose the points, I could find that out. But that's what ends up happening. I'm really not going to worry too much about making sure that you have this stretch out. All right, that should be about it for today. Have yourself a good long weekend. We'll see you guys on Monday. Hopefully, everybody will be back.